this event and for the invitation. I would like to present you the topic is about circular economy and potential application in Cyprus. So, what is the circular economy? As you can see in this diagram here, circular economy is the economy that we would like to reach, and we have to abandon the linear economy, and we have to reach the circular economy. The reason is in the linear economy, much waste is being produced, and this is bad for the environment and for the economy. So our planet and our economy cannot survive if we continue with the take, make, use, and throw away approach. We need to retain precious resources and fully exploit all the economic value within them. The circular economy is about reducing waste and protecting the environment, but it's also about the profound transformation of the way our entire economy works. By rethinking the way we produce, work, and buy, we can generate new opportunities and create new jobs. The mixed smart regulation, innovation, and incentives at EU level and local level will help business, consumer, as well as national and local authorities to move from the linear economy to a circular economy. And I will present you how we can achieve this, in my opinion, and what are the potentials in Cyprus in order to reach these goals and this target. As you can see, an important aspect in the circular economy is to minimize the extraction of natural resources, including energy, metals, and also to minimize the use of the incinerators and to minimize the waste that end up in landfills. So the European Union has set some directives and some legislation regarding the waste prevention, the municipal waste, the packing waste, the food waste, the by-waste, and the residues, and the circular raw materials. And the European Union has set some directive regarding the regulation. For example, the individual waste streams, the number of the individual waste streams that will end up in the landfills, and also has initiated some kind of funds regarding waste valorization, and as a set regulation regarding landfill tax and gate fees. So, talking about Cyprus, as you can see, in Cyprus, we are producing a high amount of waste compared to other nations. We produce around 550 to 650 kilo per capita. It's one of the biggest in Europe. And as you can see that diagram, also the majority, a high percentage of this waste end up in landfills. And this, by 2030, should be no more than 10% of the municipal waste that should be sent to landfill. So we should find another ways to divert or to valorize this waste, the municipal waste. First target or the first measurement should be waste prevention, to produce less waste if it's possible. I will talk about this later. For example, a ban of landfilling or of separately collected waste. For example, the waste from the restaurant should be easier directed somewhere else apart from landfills. Or the amount of municipal waste to be reused or recycled. I will talk to you about the technology. So here in Cyprus, we are far behind the goals regarding, as I told you, about municipal solid waste. We are far behind glass. We are okay. We have reached the target regarding metallic and paper cardboard, and we are behind the recycling of wood, and we are in an average level regarding plastic. So Cyprus, that has one of the highest volume of landfilling in EU, it will need to divert waste from landfills. The challenge will be to implement, first, in order to achieve this, we have to do waste separation. And this is not, do not take place in Cyprus. And we should target the waste separation and the municipalities, yes?
Will we be able to have your notes at the end sometime in electronic form so we don't have to take notes? Or
yes. I will give the presentation to Andrea or to Mr. Spiro, so I can even email you. So waste separation is important, and the government should target the municipalities, the community in communities in order to achieve these goals. So by waste separation, the organic waste should be separate from the other waste. So it could be treated, it could be valorized in other ways more effectively. Will not be mixed with metal. Divert, and also this kind of waste separation will have high values. So then I will talk to you about the technologies that we can use for the different, so it could be streams, it could be treated, it could be valorized. So the main technology one of the main technology that can support Cyprus to move from the linear to circular economy is the anaerobic digestion. Anaerobic digestion, it's a technology that can digest, can treat the organic fraction of the municipal waste, or can also be used for the treatment of garden, that we can use for animal or industrial organic waste. So the final outcome of the anaerobic digestion is biogas. That biogas can be used for electricity and heating. And so the outcome is you have the waste, and the outcome is electricity and energy, and those can contribute to increase of the renewable energy treated percentage in Cyprus compared to the fossil fuels or other type of or oil or petroleum. So another important advantage of the anaerobic digestion is that the biogas can be upgraded and can be converted to methane. So if it can be converted to methane, then can be used as a biofuel. And this is important because the methane it's already compatible in many car engines, and the technology is there. For example, Sweden is already using this kind of technology, the upgrading of biogas to methane, and the car that they use methane, so they have some benefits. For example, is that the biogas they can upgrade in many places. So if it can be converted without methane, then can be used as a biofuel. This is important because the methane promote the anaerobic digestion already compatible with many countries the current biogas value and the technology is there. For example, Sweden is already using this kind of technology. The upgrade of the biogas without methane, this value is higher. So it's a way that the government should target. Also, in order to promote the anaerobic digestion, In Cyprus, there are 15 anaerobic digesters. So some of the waste from the municipalities can be inserted in that digester that we have for animal or manure. I mean, the biogas digestion without promoting digestion. So it's a way that the government should. Another technology is composting. Is transfer of organic waste to fertilize. This technology requires air in order to be take place and can be applied as well in communities that are far away from the center, and there are no other ways to divert the waste to the digesters. As I told you, we have to avoid the landfill. Requires air. So the final product from the composting is the transformation to fertilizer. Can be applied as well in other technologies that are not mature or far away from the center. Used for specific streams. And there are no other ways to divert the waste to digest extraction from olive oil. We have to avoid the landfill, diesel, bioethanol, biohydrogen, metal recovery, bioleaching from and electron weaving can be applied to extract metal from batteries or electronic waste. So this is several other technologies how that achieve this, we can consider them for specific streams in Cyprus. So, for example, for the wet organic waste, anaerobic digestion, you can see, is considered a good solution. Then it's composting and compaction with land recovery. To you about the technology that we can use the digester in that case. I will explain you several examples that the wet organic waste economy can be applied. For example, is considered a good solution of sludge. Composting and sludge digestion from the waste of the plants is the last many fronts of digester is considered a problem. But there are some technologies, for example, phosphorus recovery. I will explain you several examples that wet organic waste can be applied. For example, biodiesel is considered an option of this type of waste. From the waste of the plants, many fronts of digester is considered a problem. There are some technologies, for example, phosphorus recovery. I will explain you several high value products. Is the challenge to implement biogas in order to achieve this. We have to do, for example, I will not get in detail now. Maybe my colleague Michalis will present you this topic later on. The winery waste. From this waste, apart from biogas or compost, phenol can be extracted. And some other compounds that have good antioxidant properties. Another stream that is already the anaerobic digestion is applied is the manure, animal manure, pig manure, but this can be applied in more farms. So the high value products is the contribution of the anaerobic digester and the renewable energy and the increase in cycle. And so the outcome is you have the waste, and the outcome is electricity and energy. That again here biogas to compounds can be increase of the renewable energy percentage inside. So to transform this stream from waste to high value added product or products. And in a recent research paper that we have published, we talk about the potential of converting spent coffee grounds to a valuable resource. So again, here apart from biogas, This can be used for soil improver, or can be transformed to adsorber. We can extract lipids for biodiesel production. And again, there are some phenolic compounds that can be extracted from this waste. Valuable resource. So again, here apart from biogas, what I have, just to summarize, is that by separating the various streams, we can, for example, we can use the appropriate technology also to transform this type of waste to valuable products. So separation from the source is an important aspect in order to move from the linear economy to the circular economy. Another example is this example that in regarding the price soil by separating instead of buying new products, for example, let's say valuable products. So separation from the source is an important aspect in order to move from the linear economy to the circular. So enables half of the labor cost to another example is like bridges, ovens, exposure that in calculate back from the income price so by separating instead of buying new products, for example, valuable products. So by separation from the source or by reusing the important aspect equipment from the linear new social waste, and this is a lot of the another legislation. It was part from the it's part of the activities that the government should be forced. So how can the circular value grow in Cyprus? By regulation, legislation, by reducing the landfilling, using anaerobic digestion and composting. We can, the government should match the people that produce, or the industries, or the municipalities that produce waste with the industries or the companies, local or abroad, that are interested for waste utilization. For example, the sludge that is produced from wastewater treatment plant, it can be used by people that do compost, or can be used by industries that they are interested in phosphorus recovery. It's important to have better knowledge of material flows, to have a separation on the source, and it's important to have to educate the public in these issues. Thank you very much. Let me know for your question. Thank you for your attention.
You take an initiative, okay, it's very nice that you're putting forward all these ideas. Are you working with the back, or you're...
I participate in a group that the Ministry of Agriculture has created. So we're discussing this kind of issue every 2 weeks. So we exchange ideas. And
is there a type of policy proposals to just come out with somehow have a team of scientists that will come up with a rounded policy proposal?
It's yes, we are exchanging idea in order to not to implement, to propose some, or to tell our opinion about some regulation, to act as a regulator in order to promote the circular economy, not by doing projects, but by proposing some ideas, by supervising or by taking ideas from what has been done in Europe and how the circular economy works in that countries, and to see the potential of this kind of legislation, of these types of measures in Cyprus. For example, this measure could be the Okay, the most important, some of these measures should be legislation regarding the taxes, or in order to promote the use of this waste, the organic municipal waste. We have to see how the separation in the source can take place, and this kind of issue.
Mr. Vyridis, we produce so many waste. Why we didn't build a pyrolysis plant in order to produce biofuels and minimize this waste?
Okay, the European Union do not promote the pyrolysis plant. Pyrolysis could be good for a specific source of waste. For example, some types of wood agricultural waste could be a solution. But, for example, organic municipal waste or food waste or some other industrial waste could be more beneficial for the environment if they go through the anaerobic digestion. Biogas can be produced, biogas that can be upgraded to methane can be produced, so can be used as a biofuel. The final outcome can be fertilized. So pyrolysis could be part of the solution, but it depends from the source. That's why it's important to separate the waste in the source, so to be able to use it and to be able to divert it to specific technology. And also we have to think about pyrolysis is energy intensive, and there are some other aspects regarding the emissions or the capital cost for pyrolysis in a large scale. So we have to take this in consideration regarding pyrolysis.
Thank you.
Any other questions? Please ask. Sure, for sure. Circular economy in Cyprus has a big potential, and we don't have any other option. We have to move from the linear economy to the circular economy. We have to set the technologies. Yes.
So if you set up an anaerobic digestion in the winemaking areas of Troves, how the gas that will produce there will go to the power factories?
Okay. Thank you for the question, Dr. Kartakoullis. The thing is, before to set up an anaerobic digester in a winery, this could be profitable. Depends on the tons of the waste, and as far as we know, wineries do not produce waste all around the year. So a good solution is to go digest this waste, or to send this waste to digesters in nearby places. So it could be, if you can find, let's say in the area, is there any farm that has an anaerobic digester, and this winery waste can be digested there, so this can be solve the problem. But as I told you before, winery waste can have high potential for recovery of phenolics, or making bioethanol. So there are many ongoing research in that topic. So anaerobic digestion is considered the last step. It's considered the last step before the last treatment step. If you have this kind of waste, in my opinion, and if you have the amount, can also examine the possibility of extracting some antioxidants, some phenolics, some other high value added compounds, and then to go for the anaerobic digestion. As far as I know, this type of waste in Cyprus go for animal feed. I think so. Yes. Don't be shy. Stella, yes. I thought that you. So. Okay. Anyone? Thank you for your attention. I will give the.
So good afternoon, everyone. My name is Michalis Koutinas. I work at the Cyprus University of Technology in the Department of Environmental Science and Technology, running the Environmental Bioprocessing Laboratory. And my talk is related to a similar problem to what Ioannis just presented. It has to do with the development of a specific type of efficient technologies that can be applied for valorizing the residues that are generated from the whole food supply chain. So if we focus to food waste, we see that there are a lot of reasons why we should target valorizing that particular resource. Starting from the fact that nowadays there is very strict legislation, particularly in the EU, restricting the disposal of these particular types of waste, and also for other reasons that which have to do with technological aspects, such as, for example, that they have high organic content, and the fact that they are renewable, that they are available all over the world, so you avoid dependencies on the supply of fossilized hydrocarbons to produce useful commodities. So nowadays we are trying to shift from the fossil-based economy to a bio-based economy. In order to achieve that, we need first of all to have technological breakthroughs. So we need to develop these technologies that will convert biomass into added value products. We also need to exploit synergies. So you have to make synergies between the industrial sector, the academia, and the chemical industry. Also, the chemical industry will need to change a lot the infrastructure that is currently used, because the current facilities used in the chemical industry are based on technologies that exploit hydrocarbons. We need to change these technologies to the technologies that we provide now through biorefineries. And the optimal way to exploit food waste as a resource is actually to try and refine specific fractions of the waste and extract pure products, and convert the rest of the biomass that remains after the refinement of the different fractions into commodities using chemical treatment or biological treatment. So these are the major products that are produced in Cyprus, and all of these production processes end up in certain residues that we have available and that we could exploit. Now, if we look at the composition of food waste, we'll see that we have there specific molecules with specific functionality. Some examples are that some compounds have antimicrobial properties, or some of the constituents of food waste might have adhesive properties. So if we treat this type of waste with first generation technologies like anaerobic digestion or composting, for example, what you actually do is that you destroy all these molecules and you lose all these functionalities that already exist there, and at the same time you produce very simple molecules like methane, or very simple products like compost. Although this is a solution that we will always follow for particular cases, this model is not optimal. So we need to increase the efficiency of these methods in order to preserve these functionalities that I just mentioned in the molecules that are already inside biomass. So what is the solution? The solution is to look at the particular residue, to look at the composition that it already has. So try to think strategies of extracting some of these molecules that are contained, purify them, and sell them as marketable products, and use the rest of the biomass through processing, either through chemical processing or biological processing or physical processing, into a media that is rich in carbon sources or nitrogen sources for fermentation in order to produce fermentation products like bioplastics, like bioethanol, like different chemicals used by the chemical industry. So this is the current situation. So currently we have been exploiting mainly crude oil. And in the past 160 years, we developed all these technologies, all these catalytical techniques, cracking, reforming, and so forth, that give us the opportunity to produce a wide range of products that we use in everyday life. This is the plan for the present and for the future. So currently, we are developing similar technologies in order to exploit food waste and other biomass-based residues as well, apart from food waste. And we are developing technologies that are environmental friendly and they are less energy intensive, trying to produce exactly the same type of products. So instead of producing fuels, you produce biofuels. Instead of plastics, bioplastics. And also in biorefineries, you can add a new category of products, which is food. You can actually produce food as well out of that using this approach. So the whole plan of exploiting biomass and food waste in a more efficient way requires two steps. The first step is to extract valuable components. The second step is to try and generate a media that will be useful for fermentation. Now, for fermentation, the components from food waste that would be useful would be the carbon sources, and carbon sources can be the content in carbohydrates or the content in oil. And for the supply of nitrogen source, you can use the protein content of biomass. Now, when you adopt the biorefinery concept to valorize the residue, you should target not to produce just a single product. In order to make your process cost effective, you should try and produce as many products as possible in order to improve the economics of your solution. Also, another message I can give you today is that there is no common solution. We have different residues in each region, and in order to exploit a particular residue, we have to design the processing. So the processing cannot be the same in any type of waste. It has to be particularly designed for a particular residue. So this is the current status. So far, we have been using food waste as a supplement in animal feed. This is a good option, but you cannot feed to animals any type of residue because of regulatory issues. Composting, which is an extended and very useful practice, but still in many cases the economics the cost is still high. Incineration is also applied, but for many types of food waste, it's not a good solution because food waste contains big quantities of water, and you have to spend energy in order to evaporate the water. So this is a suitable technology for specific types of food waste, and of course landfilling, which is a terrible option that we all want to get rid of. So by adopting a biorefinery strategy, you actually improve the sustainability of the waste management in food industries by reducing the use of landfills, by reducing all the bad consequences associated with the use of landfills, like the uncontrolled greenhouse gas emissions or the leaching of water to the ground. And you also need to keep in mind that not all the residues from the food supply chain have the same value for valorization. So starting in this graph from the bottom and going up, we have an increasing potential for valorization. So in the bottom you get more heterogeneous mixtures, like the mixed kitchen waste, where the composition is might be different from one day to another. They're harder to trace. The traceability also is an important aspect. While on the top, you get the crop residues, such as, for example, from vegetables or fruit production, that they could have good traceability in many cases, and also they contain both components of high value that you can extract, and they can also serve as good supplements for microbial fermentations for biofuel production or for other fermentation products. So I'm going to show a particular example for the valorization of citrus peel waste that we have developed in our lab, working in the past few years. So citrus waste is a very important residue for Cyprus. The annual production worldwide is about 121 million tons, according to the Food and Agriculture Organization. It's estimated that about 25 million tons of citrus peel waste worldwide are generated every year. Now, in the juice manufacturing process, you lose about half of the initial mass of the fruit. So 50% of the fruit is peel waste, and the current management practices is that it's either fed to cows or it is disposed in landfill. So in order to develop a biorefinery and try to valorize this residue optimally, you need to have a look at the composition. So the composition of the waste is actually made of the peels, the seeds, and the segment membranes that remained after juice extraction. And the main constituents is pectin, which is about 42%, soluble sugars, about 17%, hemicellulose and cellulose at 10 and 9% respectively. Also, you get an amount of other useful contents, like starch, for example, of proteins that are useful for fermentations. So as I mentioned at the beginning, you have to look at this complex composition and try to identify extraction products. So which of these constituents could give you added value if you extract them and try to purify them and sell them as marketable products. So one is pectin, because it has a high content and it has a lot of applications in the food industry. The second one is the essential oils, which also have a lot of applications in many different sectors. So this is a simplified schematic of the technology that we have developed in the lab to extract the essential oils, where we use simple water distillation process in order to recover the essential oils. Then after acid hydrolysis and precipitation, we recover pectin. We further hydrolyze the polysaccharides enzymatically with the addition of enzymes, and then we end up with two streams. We end up with an aqueous stream, with a liquid stream, and with a solid stream. So the liquid stream is used in fermentation. So we have tested two different fermentations, one for the production of succinic acid, which is an important chemical that is used as a starting material in the chemical industry, and also to produce the biofuel. We have exploited the production of bioethanol. Now, in order to close the loop in the waste management of this particular industry, you need to find the global solution. So you need to develop a zero waste technology. So we have tried managing the solid residue with anaerobic digestion to produce biomethane, and we have also tried the application as a fertilizer in agriculture in order to give a global solution. This is a more detailed graph of the technology that we follow, and some data we have extracted with distillation. Nearly all the essential oils that are contained in the mass, we recover about half of the pectin that is included in the waste. And then we have tried different configurations in this process. We have tested the combined hydrolysis of polysaccharides with chemicals and biologically, and we have also tested what is the effect only of acid hydrolysis. So when developing such a process, you want to measure different parameters in the liquid stream that you produce. For example, we characterize heavy metals, which can be either inhibitory for microorganisms, or they could be acting as cofactors, sometimes for the strains that we use. You can characterize different hydrolysis conditions, like you can vary the temperature, you can vary the reaction time, the amount of solid that you add, and always your criteria is how much sugars are released during this process. You can optimize your biological hydrolysis by testing different mixtures of enzymes and different contents of enzymes. But the decisive factor is always economics. So in all these technological options that you compare, you want to see what is the financial impact of the different options, like here where we compared the processing only with acid hydrolysis and the pre-processing with the combination of acid and enzyme hydrolysis, where from the techno-economic evaluation that we did, we realized that the additional biological processing was not cost effective, as the extra cost was more than the additional revenue that we were going to make by adding this additional processing step. Now, in terms of the management of the biorefinery residue through anaerobic digestion or as a fertilizer, we characterized methane production from three materials. One was the residue that I mentioned before from the biorefinery, as well as the raw citrus peels or citrus peels after drying. We saw that all three materials have the same potential for biomethane production after adaptation of the microbial culture. And from the application as a fertilizer in lettuce crops, we realized that this material had the capacity to increase the content in potassium, phosphorus, and nitrogen, but at the same time, it stressed the plants, so it would be more suitable for a plant that can resist low pH values, as our residue had a low pH. So the main conclusions from this concept, from the biorefinery concept, is that it's a more efficient way of treating biomass or treating waste from the food sector. It gives you the opportunity to be able to exploit these residues more efficiently, producing added value commodities. There is no unique solution, so there is no unique processing. You have to design your processing according to the residue that you have in place, and always you need to calculate the economics in order to see which options are cost effective. So I would like to thank you for your attention, and I would be happy to answer any questions you might have.
Something.
Yes, sir.
Nowadays, food globally is limited. You believe that the implementation of these biorefineries new technology may increase the risk in the future to produce food-type products just to produce energy or high-value products?
This is a very important issue that you need to take into account. So, for example, corn is a very important crop that is used in some countries for biofuels production. But we know so far that this practice, if you use the whole crop, might generate spikes, big increases, very fast increases in the demand of these crops, which consequently they bring very big increases in the price of that particular crop. And in some cases, you can leave the poorest part, the most poor parts of the population hungry. So you need to focus on residues from fruit production. So you need to focus on the waste, and these feedstocks that you apply in biorefineries should not compete with food production.
Thank you.
Any more questions?
Do you plan to go to other crops in Cyprus besides viticulture?
There are several options for the development of biorefineries. One option would be the winery industry and the residues that are associated with both with the crop production and with the production of wine. Ioannis gave some data before regarding some of the compounds that you can extract. But I think in Cyprus it's also a very important residue that could be exploited. So in each country, I would say you need to focus on the resource. We need to exploit the resources that are available. So the resources available depend on the particular products, food products that you have. So if there are no more questions, we can go to the next presentation. Thank you very much.
We can have a 5 minutes break. I will continue.
with the Autonomous University of Barcelona and IRTA, smartphones for digitizing agrifood systems.
Hello everyone. I am a Marie Curie Research Fellow at the Autonomous University of Barcelona at Adaptation, and I'm going to present you the latest developments for smartphone application in agriculture for digitizing agri-food systems. So the problem that we are facing today is to ensure that the food production would be able to cover the needs of the continuously growing population. And also we must make sure that the levels of food safety and quality must be kept as high as possible in order to prevent food waste and diseases. And data-driven methods can help to address this problem by creating big data in order to extract information and trace the viability of the agri-food systems, both in time and space, in order to get the information that we need to optimize their performance. In addition, data-driven methods can offer traceability, which is needed for food safety. And smartphones are a key technology to create the big data due to their low cost, the huge volume of users, their ability to be connected with high-end sensors. So the smartphones are actually mini computers. They have fast processors, large internal storage, high-quality cameras, operating systems, and high-speed mobile connectivity, which is their major advantage. And they can be turned into mobile diagnostic platforms by either integrating or augmenting them with different kinds of sensors. We can even run biomedical tests on them and many kinds of scientific measurements without the need of advanced laboratory instruments. And this is expected to create new data sources that will be available for everyone. And it will lead to the so-called democratization of data. And in the field of agriculture, this will totally reshape the sector by creating new practices to help to solve the problems that I mentioned before. So a great example of how the smartphones can reshape is the near-infrared spectroscopy. And for those that are not familiar, near-infrared spectroscopy can monitor the different vibrational levels of molecules and obtain spectra from samples, and from the spectra to estimate the chemical composition of the samples. And several big companies like Hoff and Brugger, they have created large spectral libraries for their big instruments that can provide fast and accurate measurements. And the whole point how near-infrared spectroscopy works is to have, this is an example for estimating the malic acid in rice, is to have a number of samples that you know the concentration of malic acid, obtain a number of spectra from these samples, and use multivariate analysis methods such as the PLS, the partial least square method, in order to find a new matrix that is called the regulation vector that better describes the linear relationship between the spectra and the different concentration of malic acids. So by obtaining the P, which is actually the libraries that Hoff and Brugger are using, you can use it to get the estimation of new unknown samples. By just taking the spectra and multiplying with B, you can predict the concentration of malic acid. And this is how most of the instruments are working. They have already stored this matrix B, but we can do the same with the miniaturized spectrometers, like this one is the photo. There are continuous advancements in the miniaturization of electronics, which have allowed those big spectrometers to be miniaturized and be the size that you can see there. And part of my research is to do this, to use machine learning methods, similar to the PLS method, to obtain the smallest possible prediction errors that can be comparable with the large spectrometers. And my research is specifically this, to create new libraries that are requested by the Spanish meat and wine industry. And you can imagine, like the hammock producers, they can have like a really low cost to improve the quality of their hammocks. They would be really happy with that. And also the smartphone spectrometers, they are already exploited by a number of companies that they are offering these solutions for consumers. There is a number of companies that is offering solutions to the mobile app to estimate, to see if the food has pesticides, if it is, if pathogens are there, calculate the ripening levels of fruit, monitor your whole diet. There's a great number of applications that is already there, but they're focusing more on the consumer side. On the industrial side, there are not so many applications, but there are a lot of companies already working on that. So in the next 2-3 years, there will be also applications for industrial applications. Also, besides of connecting the smartphone with the spectrometers through the Bluetooth, you can use the real camera of the smartphone. Where in this study, they have used chemical dyes that they were used in microfluidic papers to evaluate different wines. Like they use the smartphone to capture the images and send them for remote real-time analysis, and the statistical process of the images was able to successfully distinguish the wines by their grape variety and their oxidation status. And also another category that is gaining a lot of attention is to integrate biosensors of the smartphones. Where the biosensors can allow low-cost and fast chemical analysis with high selectivity. They contain biomarkers that they can interact with the target molecule and produce a measurable signal, which is, in this case, is fluorescence. So you can easily integrate the biosensors, as you can see in the image, on the smartphone, and use the camera to detect the fluorescence signal. And there are like a number of research papers that they have shown the ability to detect E. coli bacteria in water and antibiotic residues in milk. And as you can imagine, there is a great potential for future applications. The continuously technological improvements in electronics are making smartphones a really cheap and reliable analytical tool. And the applications that they will soon emerge, they will have a great socio-economic impact, especially for solving the problem of food security. And all the time, there are new technologies entering the field. Very recently, IBM used blockchain technology from the Bitcoin, you are familiar with that, to create a cloud platform that is called Food Trust. This platform can trace the whole value chain of a food product. And this traceability is very important for the consumers. An example is the obtention of the olive oil. By using this platform, you make sure that the olive oil that you have bought is not altered. And of course, there are many challenges until the total adoption of these technologies. First, above all, is the private security of the data, to make sure that the data are not used to cause any harmful consequences to the people that have created the data. But the future, it seems that the smartphone will be a tool that will be used in different sectors of agriculture and the food industry. So I would like to thank the American Embassy, the public affairs sections for organizing drinks, especially spiros, harito, and blended liquids. And I would like to acknowledge financial support from Marie Curie Fellowship.
Any questions?
What type of molecule is this fellowship?
It's a
Postdoctoral?
yeah, it's a co-founder.
And what is the topic exactly is dealing exactly with fruit crops or wine or in general about
General agrifood. If the exercise I'm working is covering the whole spectrum from genetics to
do you have links also your university links with universities related to the food sector?
universities.
Yeah, or research centers. I mean, your university in Barcelona.
Yeah,
Is it connected with any
it has a faculty
faculty of agriculture,
like
food science?
it's food science. There is this crack.
Right?
Yeah, if you know it.
No, I'm not.
Yeah, Cresa.
Later,
And yeah, all these are like a collaboration
so
of UAB and ISTA.
Okay.
Yeah, can you share the
Yeah, I would like to
Yeah.
please help me.
What kind of monitoring devices and how developed they are? Do you have in connectivity with reference?
So
What type of information can you?
it depends from this step, like depends what you want to measure. We need to, you know what you want to measure, then we'll take a large number of samples. This is called the calibration step. We take their spectra and we'll calibrate the spectrometer using these methods in order to detect it on unknown. It is very something demanding, takes time, and usually has a high error at the first year. You need to collect as much as possible data in order to perfect that predictive model. But it depends usually from what you want to measure. If it is something really difficult to measure, then it would be also difficult to use it as an evidence. If like the big ones here, like this, the Hoff and the Brugger family, they have already a solution of that and it works well, then it will work well on the small spectrometer. Because we will use this to the big instruments to calibrate the small one.
You only measure concentrations, or you can measure maybe disease severity or diagnose a disease on a plant or something?
If it is related with a chemical change, like the levels of chlorophyll, that it is so we can measure the spectrometer. We can take chemical measurements. So if it is like a change in the leaves that you
can correlate it.
yeah, we can correlate like if it is irregular. Yeah, we can do that. It's something that one of the projects that we want to do.
Mr. Ioannis, he's from the Agriculture Research Institute, and he will talk about the research and development on agricultural robot sprayers. γράφει απλά.
So, hi, my name is George, Adamides. I'm with the Agricultural Institute. I'm going to present to you our work on agricultural robot sprayers. This is work we did with the Open University of Cyprus, the Hellenic University, and at the Ben Gurion University in Israel. I'm going to start with a brief definition of what is robotics. So robotics for agriculture is considered to be the domain field of systems able to autonomously perform coordinated electronic actions on the basis of processing of information acquired through sensors, with the aim to support farmers in doing some agricultural tasks. If you look at these two photos here, and ask you what is simpler to do to pick strawberries or to assemble a cart for humans like us, the obvious answer is it's much easier to just pick strawberries. It's much harder to assemble a car. This is not the case for robots. For robots, it's the opposite. It's much easier for them working in an industrial setting, assembling a car, than working in the field, doing some agricultural task. And this is so because in the industry, everything is set. The robots are programmed to do, and everything around them are in their place, set, all the screws in the right position. They reach with their robotic arm and they screw, their work is done. In agriculture, things are much more difficult or complicated, let's say. As you can see here, on this strawberry vine, there are strawberries that are ripe. Some other strawberries are not ripe. Some are in the flowering stage. And then we have different shapes, different colors. Strawberries and other crops require different handling, how to pick a crop. So these things make the work of the robot much more complicated. Besides this, the robot cost is still very high, and this is why, even though the technology has moved, we do not really see that many agricultural robots in the fields yet. Efficiency is still an issue because currently the accuracy for detection is close to 88%, and this is far below the expected from farmers, which is about 95% detection. And like I mentioned, agricultural tasks are very difficult. Robots navigate in uneven terrain. They work under volatile weather conditions with sunlight, wind, shading. So this puts a lot of issues to the research and struggle with vision, navigation, the end effector. To select crops is one thing. To grasp is another thing. For us humans, it's easier to reach and pick it, even if it's behind leaves or if it's behind other strawberries. So the robot is not that easy. And then the work that I will present to you here is about spraying, agricultural robot sprayer. So these are the current methods used for spraying. Either the human is using a hand sprayer or mechanized. But you can see how much spraying is spraying to the environment, right? And also you could see when the person was spraying, he was doing like this, maybe so he was spraying the same plant more than it needed to be sprayed, right? So what we thought is that this is the way to protect the farmer, first of all, from the exposure to these chemicals, protect the environment by using less pesticides, and also the consumers at the end of the day, because if you spray less on the crops, the consumer will consume foods with less chemicals. So we got a small robot, robotic platform. This is the work that we presented here is about an experimental robot sprayer. It's by no means a robot sprayer that you will see someday in the field. We wanted to do some work to prove the feasibility of this work. So we got the platform, a mobile platform. We installed an electric sprayer on this platform and some other cameras. The second stage here, we did some tests in the field and we found out that it was very difficult to navigate with just a single camera. So on the second version, we added a camera at the back of the robot so the operator can see what is around the robot. And the final version, we also installed on this robot a robotic arm, which has 6 degrees of freedom, so it can move up, down, left, right. So the whole idea was not to have a robot to take the job of the farmer. We wanted a robot collaborating with the farmer. So in this sense, the farmer is in a safe environment, away from the field, and the robot is in the field. But then you need to have some kind of communication between the two. So this is the concept here of this framework, is to have a user interface to allow the farmer who is in a remote place to feel like he's in the field. So this is what we call telepresence. You are away from the field, but it's like you are in there. So the robot was able to autonomously move around, do the recognition, do the spraying, and the farmer was in a remote place controlling or at least supervising what the robot is doing. So this is what we call human-robot interaction awareness, which is the understanding that the human has of the location, the activities, the status and the surroundings of the robot, and the knowledge that the robot has of the human commands necessary to direct the activities and the constraints under which it must operate. So we have, from this work, we have developed a set of user interface guidelines for engineers to follow when building user interfaces for such systems. Platform architecture and scalability, like Andreas explained earlier, technology is moving very fast, so systems need to be scalable. And error prevention and recovery. I'm going to give just a simple example. When we use computers, if we make a mistake, like in Word, we accidentally deleted a paragraph, we press the undo button, it comes back. In the case of robots, I think we are talking about a robot that is pruning. If there's if by accident it cuts a branch, there is no way to undo that. It's cut, right? I understand that. So there needs to be mechanisms to prevent errors, or at least to be able to recover from such errors. This user interface is easy to understand. The information presented should not be everything around and let the user decide what to do, but it should be presented in a way that the right information is presented when it's actually needed. Robust data awareness is what we talked before about HRI awareness, the knowledge that the robot has about its own systems. So if it's going low on battery, it should give a message to the user that, you know, my battery is getting lower, we have to stop, or I have to go and charge it again. Or if it's the spraying liquid is going low, again, it should give such messages to the user. Efficiency, let's say about user interfaces and efficiency. What we did here is when the user is controlling the robot, instead of using the steering wheel, we had a plain keyboard with just 3 buttons. So it was easy to navigate in the field. The robot environment surroundings awareness. I talked about the cameras and other sensors that are on the robot, so the user who is remotely has an idea about the surroundings of the robot. The cognitive factors, such user mental models or metaphors, for example, the battery example I gave you earlier, or we had a small icon with the shape of the battery, so it was immediately easy for the user to understand that this icon refers to the battery of the robot, or the proximity sensor, the ultrasound sensor. It was like in what we have in our cars. So it has 3 colors: red, green, green, yellow, and red. If the robot was away from an obstacle more than a meter, it was green. If it was between 50 centimeters and a meter, it was yellow. But if it was below 50 centimeters, it was red. And we also had an alarm, a big alarm, to make the user aware that the robot was going to hit something. So we built some user interfaces like this ones here. This is the battery level that I was talking about, and this is the proximity sensors. This is the main camera on the robot. And here we have 2 other cameras, one to show where the robot is spraying, and another one to show what is around the robot. This is our robot sprayer. Let me show you this little video. So the operator here was about 500 meters away from the robot in a room, and the robot was moving along in the vineyard, spraying like that. And like I said, the 3rd version of the robot, we installed this robotic arm. It's an effector which can move in 6 directions. And this was done for targeted spraying. So instead of mass spraying that, you have the robot going and spraying everything, you can just pick what to spray. This is the work from our colleagues in Israel, and it's showing exactly what I just said. So you see, the robot is spraying just on the red images. This is what we call site-specific targeted spraying. Okay, this is the robotic sprayer. It's avoiding the yellow ones. It was programmed to just spray when it saw a red color. So you can see that this is a much bigger robot device compared to ours. So the experiments took place in Cyprus, in Rhodos Mountains. This is where the operator was situated. This is our robot here, and it was operating in the field around here. And what we wanted to test was the user interface of this robot teleoperations. We had 2 number of views, either a single view or multiple views, 2 different devices for controlling the robot, the keyboard and the PS3 gamepad, and 2 types of output devices. The user was either watching through a TV or wearing digital glasses. So what we found was that with one camera, you can see this is what the user was seeing, but with all cameras around, here you do not see that there is a bucket in front of the robot wheel. If you just have this view and you continue going, you are going to certainly hit the bucket, right? Also here, if you're just using one camera, you cannot exactly know where you are spraying or how far away from these lines you are. So we have this end effector here camera, and the user could exactly see where and what they are spraying. And these are some examples of what we found in the field: branches, rocks, boxes, and of course we have accidents, right? Everything. So, main results were the participants were more effective, meaning that they had fewer collisions and were able to spray more grape clusters using the multiple use user interface. In the single view user interface, the participants require significantly more time to complete the task than when they had the multiple views. Also, with the PC keyboard, they require significantly less time to complete the task. It was more easy for them to navigate with just 3 buttons instead of using this gamepad. The perceived sense of presence, that meaning that they felt that they were actually in the field, it was much easier when they were using the multiple views and the PC keyboard condition compared to the single view and the PS3 gamepad. The PC screen contributed significantly less to the workload index compared to the head-mounted display. We found out that when the users were wearing the digital glasses, it was making them feel dizzy. So they felt more comfortable when they had a monitor in front of them. HRI awareness is key in efficiency and effectiveness in robot teleoperation. With this framework, the human-robot collaboration, the detection rate was increased to 98% of the spraying clusters, and also the spraying material use was reduced by 50%. So in conclusion, spraying is always going to be here. Farmers will need it. Robotic sprayers can be used though to reduce the amount of pesticides used, remove the farmer from the dangerous environment, but not take it out of the loop, to keep the farmer in the loop, and limit, of course, the environmental pollution. This framework was proposed, it was built, and it was tested in this experimental setting. Issues of user interface design and collaboration were evaluated and discussed among researchers. And the proposed concept for site-specific robot sprayer provides a more reliable and simplified system, higher efficiency for target detection, keeps the human in the loop, but removes them from the pesticide chemicals, and ensure less pesticides usage. Here I have a list of publications if you're interested to read more details about this work. Thank you very much.
Questions?
Yes.
This was a very interesting presentation, and I was wondering, the sprayer you showed us, did you evaluate at all the position of the spray on the leaves or the red branches, or no?
No, for this specification we did not evaluate that.
And then another question, which is more general. So, would you call this one a robotic sprayer or a remote controlled one? Which is the difference between the
Yeah. An autonomous robot is one that you press the start button and it's able to autonomously, without having any human intervention, deciding I have to spray this, I have to spray this, I don't have to spray this. This is an autonomous robot. A teleoperated robot is one that some aspects of the robot can be done autonomously, and some others can be done with human intervention. For example, the navigation, the robot moving in the field, in some cases it was autonomous, and the farmer was just selecting what to spray. And in other cases it was vice versa. We had the farmer navigating the robot and let the robot decide what to spray. So it was mixed methods. Okay. Thanks.
You guys have a very short break, 5 minutes until we set everything up with Richard, the presentation.
to chat with you guys today here over Skype. I'm not sure what's been done in the way of introductions already, but my name is Richard Hoff. I'm calling today from Washington State in the Horse 7 Hills AVA. I work for a company called Mercer Ranches. We're a diversified farming organization that does a lot of row crops as well, but we have a little over 1,300 hectares of vineyards that I manage. And I would say we're very heavily mechanized compared to most people in the area and really probably in the United States. And most of what I'll be presenting today has been kind of developed over the last 4 years, this program. I'm going to attempt to share my screen now so you can see the PowerPoint. Are you guys able to see the PowerPoint clearly?
Yes.
Yes.
Okay, great. So, one thing I'd like to start with, I feel like when people talk about precision viticulture, a lot of, things like fancy NDVI maps and drones and stuff like that comes to mind right off the bat. But I think there's a good mix of both smart technology and what I like to call dumb technology, things that are more controlled by the operator and by the management team. When I think precision viticulture, I more think about, achieving your yield goals and quality goals in a consistent manner is more what I think. And so, to me, the end does justify the means. And there's a lot of different ways to achieve precision in your vineyard. And I'm going to present, again, some very high-tech ways and some very low-tech ways that we've basically made to work for us. To me, really, the precision comes from the expectations you set for your team and the way your management team implements these operations. So when Andreas first reached out to me, he asked me there was a few different topics he said you guys would have interested in, and just due to the constraints of time, I don't feel like I could cover everything. Basically, my plan is to cover a year in the vineyard, in one of my vineyards, basically from pruning all the way through harvest, and just talking about all the cultural practices that we're doing and the technology and machines we're using to accomplish them. Just to give you a few really quick state facts about Washington so you guys can have an idea of what kind of vineyards we're working with here. We typically operate with a 2-trunk bilateral permanent cordon. So all the vines look like a T. We have a permanent trunk, and then it splits off into 2 permanent cordon arms on the trellis wire, and we're spur pruned. And then we have typically vertically shoot position canopies, so we have movable wires on both sides of the canopy that we move up the trellis to get a vertically shoot position canopy. Vine spacing varies, but the majority of our acres are about 2.4 meter rows by about 1.5 meter vines. Vines per hectare varies from about 2,000 to 2,700, depending on spacing. We grow about 25 varieties, but for sure by acreage, the vast majority are planted to Cabernet Sauvignon, Merlot, and Syrah for the reds. And for whites, we're mostly planted to Chardonnay, Riesling, and Sauvignon Blanc. Eastern Washington is very hot and dry. Most people who know anything about Washington that haven't visited here only know about Seattle, which is very green, very wet, but there's a huge mountain range. The Cascade mountain range separates Seattle from central and eastern Washington, and this side of the state is extremely arid and extremely hot during the growing season. So we get about 100 to 200 millimeters of annual precip, and most of that occurs during the winter, not during the growing season. And our growing season is characterized by high solar radiation as well. We get over 300 days of sunshine every year. With that intro, I'll just give you just a brief summary of all the things I was going to cover today. So again, I was going to look at a year in one of our vineyards and kind of talk about pruning and all the operations that lead up to and include harvest. So at pruning, we're utilizing a mechanical tool made by Poulenc, a French company, and the tool is called the TRP, which is a French acronym that I can't tell you exactly how to pronounce that, but it's basically an optical pruner. So I'll have pictures of all these devices that I'm talking about later to be more clear. But this is basically an optical pruner that tracks our cordon and allows us to prune mechanically. And then we will come up later after bud break, and we will use another tool that has mechanical barrels and whips to remove all of the suckers from our permanent trunks, as well as accomplish shoot thinning on our permanent cordons. One area that we have not fully mechanized, that we're still kind of in research and development in our own company, is wire movement for our vertically shoot position trellis. So I will show some videos of an Italian tool that we've demoed called Vignetinox, made by Basilia. And we're also using, for the last couple of years, a tool made by Pelonk, a wire lifter there as well. I would say neither of these tools are really quite field ready for what we're looking for, but we're still playing in-house, but it's definitely moving in the right direction. And then after we get the wires up, I'll talk about how we're accomplishing fruit removal to achieve our yield goals mechanically, and also leaf removal for quality reasons. And then after that, I'll talk about how to use NDVI mapping to separate different grape quality in the field and harvest selectively. And then I'll wrap up talking about the technology we use to accomplish mechanically harvesting and destemming in the field. So just for the sake of time, again, there's things that I just don't have time to cover today. I'd be happy to cover any of these topics if we have a lot of time in the Q&A time after my presentation. But we are accomplishing weed control and basal sucker removal via herbicide sprayers. We control our irrigation system via telemetry, all of our irrigation valves, pumps, and wells. We have a lot of different soil moisture monitoring technology, including neutron probes, capacitance probes, tensiometers, and we're also using a couple different companies that use predictive algorithms based on NDVI of the field or based on proprietary formulas that they have put together using years of weather data. We also use GPS-controlled fungicide sprayers, so I'd be happy to cover any of this additionally in the Q&A if there's time. Okay, so let's start with a year in the vineyard. So we start pruning typically in December for us, which is a little early, but just due to the amount of acres we have to cover, it necessitates starting that early. And the reason it's early is because we do occasionally have winter freezes that could cause some level of primary bud damage and might necessitate leaving a few more buds. But the nice thing about pruning mechanically is, although this is a very precise unit, we are leaving more buds than we need to accomplish our yield goals. So if we do have a winter freeze, we kind of have an insurance policy built in of having more yield than we really need to start with. And then each of these steps that I'm going to outline later basically subsequently reduce our yield a little bit at a time until we get to our final goal. So this is a Pelonk tractor that you're looking at here. And it's a multi-use tractor, so at the end of this presentation, you'll see me talking about this harvester in the context of using it as a harvester. Right now you're looking at it, it's a front view, it's an over-the-road tractor, it has a tool arm installed with the precision pruner installed in front of it. So if you look at the green arrows that I just put up on the screen, those are pointing at the pre-pruning mulchers. So basically those mulchers run out in front of the tool and they are eliminating 75% of the canopy and turning it into waste. And it's not as good as a standard mechanical pre-pruner, but it's good enough to where we don't need to mow or flail chop after pruning. So it does get it into small enough debris where you're able to walk in the vineyard freely without having to worry about it. These two lower arrows are pointing at two vertical disc blades. And so when you're going in the vineyard over the row, you can imagine this unit will close and those mulchers will overlap by a couple inches. And those vertical blades will basically be riding right along the cordon, basically sliding right along it. And those are the dumb blades on this tool. Those aren't automatic at all. They're just going to follow the cordon, whatever direction it slightly varies as you drive down the row. And that's going to cut any side-facing or downward-facing shoots that the precision blades that are in back will miss. So now we'll look at a different view. This is a side view of this unit. So now you can see a little easier the tool arm coming off the top and the precision pruner hanging off of it. So this red bar that I have here indicates the sensors. So there's sensors on both sides of this tool that basically go on both sides of the planted row. And on one side, it's a full bar sensor. On the other side, it's two optical eyes. And they're basically constantly searching for the cordon, the permanent wood structure that's on our trellis system. And I can set it with a 50 millimeter range to either prune 0 millimeters at the cordon or up to 50 millimeters above the cordon. And basically, about every 200 millimeters, it's adjusting those rear blades to correspond with where the cordon is, so that you can be achieving a pretty consistent height above the cordon as you're traveling down the road. So this yellow arrow indicates where the rear blades are. So there's two horizontal blades, and those are the smart technology part of this. So those horizontal blades are moving vertically up and down and tracking the cordon based on what height we set this tool to. And again, there's about a 50 millimeter range you can set that to. And those blades are basically just saw blades. So it's just, they're 14-inch disc blades with about 80 teeth per blade. That's about 35, 36 centimeters is about the diameter of these blades. And they overlap by about 20 millimeters. And they have about 5 millimeters vertically in that overlap area. And they spin about 2,000 revolutions per minute. So here's a quick video in real time of this unit operating, then I'll follow it up with a slow motion video. So you can tell my company has really good insurance, right, with how close I'm getting to it. Okay, there it goes. So we travel with this tool really depending on terrain and how aggressive we're trying to be with the pruner. We travel probably about 3.25 kilometers per hour, I would say, on the high side. And on the slow side, we might be at about 2.5 kilometers per hour. So here is this for block, we're actually pruning for pretty high tonnage, so we're not getting extremely close to the cordon. We're probably averaging, 2 bud spurs, getting a few 1 bud spurs, but also getting some 3 and 4 bud spurs. And our most aggressive blocks will actually sometimes scrape the cordon at our most aggressive point in the row when we try to get that close. So here's a slow motion video of that going again, so you can see a little easier what it's doing. Sorry, I just muted that. So you can see it opens and closes around the tall posts. It has metal guards in front of the blades that do that automatically, so the operator doesn't have to do that. And so, this will be basically a final pruning pass for us. What we'll do to follow this up is, because it opens and closes around those tall posts, we'll send people into the vineyard, and they'll basically go in at a walking pace, and they will eliminate the vertical canes that got left on both sides of the posts. So here's an after shot, kind of before and after the same shot. You can see what the vine looks like after that pruner's come through. In this case, we were pretty aggressive. Here's a close-up. The cut quality is pretty fantastic. You do have to change those horizontal blades, the precision blades, quite frequently. We basically are on probably about every 4 hours change out, and have somebody sharpening blades 24 hours a day. So here's a few close-ups. My early years of starting this, I was a little concerned about how non-selective the tool was, since you're only selecting a vertical height above the cordon that you're pruning. Sometimes you're not cutting 1-year-old wood. Sometimes you're only leaving 2- or 3-year-old wood. And obviously vines will, they're pretty weedy. They'll push basal buds and latent buds, but I was kind of curious at what frequency they would and how likely it was that we maintain good pruning positions for the future. And I've been really happy with how that's worked. I do irrigate a little more aggressively pre-bud break to encourage a very healthy percent of buds pushing to make sure I do maintain good pruning positions for the future. But this has turned out really well. So we've mechanically pruned our vineyard. We've had a small crew come through at a walking pace and remove the vertical shoots that were missed as the pruner opened and closed around our tall posts. And now we have maybe about 6 inches of shoot growth here after bud break. And now we're looking at desuckering our trunks and shoot thinning our cordons. And you'll see here the tool that I'm showing also has a flail chopper in the back. So we're also mowing the vineyard at the same time, which, you know, saves a pass, which is really nice. And also prepares that row for people to come through in a month and move the wires up to vertically shoot position that canopy. And so this tool as it's pictured is how I'm using it in the current form. I'm going to show you a series of videos, kind of the evolution of how I've adapted this tool over time to make it work better for us. So in the early years, we weren't able to prune quite as aggressively as we are now, so we had a lot more buds and therefore a lot more yield than we were trying to achieve. So we had to be pretty aggressive with the shoot thinning. So in this video, you'll see we're using like a propeller-style head, and that's actually hydraulic hose that we're using for the whips that are going to be striking the top of the cordon. With this operation, it's really important that you do it early if you're going to be striking the top of the cordon like this. You really want to do it at about 2-inch shoots to maybe 6 to 8-inch shoots maximum. If you really go much higher than that, you start damaging shoots and breaking them versus removing entire shoots. Here's another video at the kind of the end of the effective range of doing this type of operation in real time here. Probably going about 3.5 kilometers per hour. Here, this is the same tool, but using the motors in the reverse direction. So now we're striking the bottom side of the cordon. So this would have been a vineyard where we determined that our yield was pretty close to our goal, and removing just the shoots that arise from the bottom of the cordon would be enough fruit removal to get us to our target. And so a much less aggressive approach. You're not removing any future pruning positions either. I've really gotten away from the previous 2 videos I showed you where we were striking the top of the cordon, mainly because it works well, but it's so indiscriminate that you really are losing some good pruning positions for the future. I just don't think it's very sustainable over the long term. This is the same operation going underneath the cordon, just giving you a taste for how big you can let the canopy get and still have this operation work. In this case, we were being a little more aggressive, so we had 4 whips instead of 2 whips on each side. And you can adjust the overlap of those whips so they actually strike up into your fruiting zone a little bit, remove some basal leaves, and knock out a few clusters that are pre-bloom as well if you want. So these next 3 videos are going to be more in line with how I'm using this tool currently. And the nice thing about the way it's set up now in these next 3 videos is you'll notice we are desuckering the entire trunk above the irrigation drip line, which is nice. So below the irrigation drip line, we are using chemicals to control the suckers, and then on the rest of the trunk, we're using this tool. At the same time, these 2 barrels, which have about 64 whips per barrel, are striking the cordon in a way where I'm desuckering and shoot thinning at the same time. And so I'm going to show you 3 videos here, basically with different levels of aggressiveness for shoot thinning. So in this first video, when we did our cluster counts early on before bloom, we would have noticed that we were right in line with our target yield, and so we don't want to do much shoot thinning. So in this case, we're mainly going to be desuckering, and you'll notice that these whips are maybe barely striking the bottom of the cordon, taking off a few of the bottom cordon shoots, but not many. And I have it kind of in slow motion here to make it a little easier to see what it's doing. But you can see we're just striking the bottom of the cordon, not removing a whole lot, and then desuckering everything on the trunk. This next video, I would say, is probably the most aggressive we use this tool. So in this case, our yield is much higher than we want it, and we're really trying to be aggressive. So in this case, it's actually going to be striking above the cordon and into the bottom of these shoots a little bit, and really taking off a lot. If you're going to be this aggressive, you really need to, you can't start at like 6 inches. You need to wait for those shoots to get at least probably 18 inches tall, because what you'll find if you're this aggressive at 6 inches, you'll remove 100% of the shoots on that cordon But if you wait until you have 18-inch shoots, you'll remove just a certain percentage of shoots, and you'll still leave plenty of good pruning positions for the future as well, arising from at or near the permanent cordon. And this third video is just an old-style head. We've actually gotten away from this size head. We were trying to see if it was a little easier on the motors, but it didn't really work the way we expected. But what you'll see from an aggressiveness standpoint is this is somewhere in the middle of being aggressive. In this case, we're really just trying to strike the sides of the permanent cordon, not below or above. Sorry, let me go back there. And so this is an example of what I brought up before. Your management team and your operators are so critical. This is very crude technology that I've been showing you for desuckering and shoot thinning, but it works extremely well with well-trained people and a management team that's taking a lot of data. So we're capturing a lot of cluster counts per linear foot to make sure we're not being mainly too over-aggressive is the main fear. It's very easy to be very aggressive with this tool if you're not being careful. But run correctly, it works very well. This is just a little bit of a before and after picture of the machine run through. You can see it does a great job mowing the rows as we're coming through. And then you can basically see the trunks. So let me find my mouse here. The trunks are clean, minus the basal suckers around the drip. We'll come through with an herbicide sprayer now that it's been shoot thinned and mowed. And that herbicide sprayer will kill all of those basal suckers. Now that shoot thinning and desuckering is complete, we would be looking at wire moving. So I'm going to show you a tool called the Viticulture made by Basilia. This is a great tool in concept. However, it's just kind of in the beta stages. So they let us demo it. It's very flimsy. The metal bent a lot. And then what we found is that when our canopies are full, this tool had a hard time navigating the wire into our posts at times. But a very interesting concept because it uses our existing wires. A lot of the mechanical wire lifters these days are actually using twine instead of your existing wires. Then you have to get out of the tractor and tie the twine on the end post, and you have to remove the twine at the end of the season. It's still quite labor intensive. This tool is using wires that we have already installed, and it's using our existing tall posts to store those wires. So this first video is in winter. It's just a little easier for you guys to see the tool putting the wire to the notches. And then I'll show you one during the growing season as well. So basically those two yellow plates are going to slap each other right after this post. And it's on a track system, so the driver doesn't have to slow down. And then it just pushes it into the tall post and then pushes it down at the same time until it finds the notch. And so you can see right here, it placed it perfectly into those notches on our post. It worked really well winter. We were really excited for this tool initially. This is the tool during the growing season. This is a small Merlot canopy. You'll notice that, so we have the wires stored on the ground at this point. And so as this tool approaches the post it's going to be clipping the wire into, you'll notice the canopy slightly starts raising right here. So it's lifting the canopy as the wire moves from the ground closer to the post. And as the driver notices he's passing the post, he'll press a button, and then this tool will snap the wire into place in the post. Here's an after shot. Again, when it was working correctly, it worked very well. What we started finding, though, is in most rows, probably, 1 out of every 3 posts, the canopy was so dense, you'd have a diagonal chute that would basically be right around here, and it would get in the way of that wire finding its way into that small notch on the post. So if this tool makes some improvements, we might be looking at going this direction. We'd have to install some aftermarket clips on our post here, though, to provide basically a bigger pocket or a bigger window for those wires to make themselves on the post. So we get our wires up. We get our wires up very early. So most people are putting their wires up well after bloom. Once there's fruit present, once you have fruit set, we're actually getting our wires up as soon as the canopy is large enough to facilitate the process. And the reason is we are using mechanical sucking cut leafers, as they're known as, to reduce crop. So these are made basically remove all the leaves in the fruiting zone on the morning sun side of the canopy. We're using them about 3 weeks earlier than intended, at pre-bloom, during bloom, and right at fruit set, to intentionally remove crop at the same time. So we're intentionally removing fruit at the same time as we're removing leaves. So doing two things in one pass. Here's a quick video of a Clemens. So there's two companies we use. This is a Clemens tool. We also use an ID David. Sorry, lost my mouse there. So this is at about full bloom that we're accomplishing this right now. And if you accomplish this at full bloom, you will remove a very large amount of whole clusters, and additionally, you will cut some partial clusters. If you do this at the end of this kind of window of availability for removing crop, like maybe a fruit set, you probably won't remove any whole clusters, but you'll remove a lot of partial clusters. So depending on how aggressive we want to be is basically determines the timing when we start this operation in a given vineyard block. So as you're looking at this tool, I don't know if everyone's familiar with this type of leafer, but you're basically just pressing against the canopy, and there's two rollers about the size of paper towels that are spinning inward, and one of them has holes in it. And then there's a fan in this box right here. And the holes in one of the rollers allows that fan to create suction and pull those leaves in, and doing it this early also clusters and inflorescences. And then it basically cuts them up and spits them out the exhaust. There's another leafer we're using that looks exactly like this one, but it's called the ID David. It's from Spain. And this one also has basically a shield that's touching the canopy. And between that shield and the deleafing head, there's a series, you can put different springs. So there's like a thick spring, a medium spring, and a very thin spring. And those springs have different sensitivities to you pushing against the canopy. And basically, as that spring allows a pin to move inward on that shield, the hydraulics on this boom will push the leafer either towards or away from the canopy. So in this way, we can be very precise with how aggressive or unaggressive our operator is being for removing leaves or removing crop as we're doing yield adjustment. Here's a before picture. You can see the leafers just over there on the left-hand side of the screen, just getting ready to make a pass here. This is what it looked like afterwards. Here's a close-up. Here's these next slides will just be some pictures showing you what the clusters look like a couple weeks later or maybe a few days later, depending on what timing was for doing the process. So again, if you do it early, you remove a lot of whole clusters, and as you move later and later, you start removing partial clusters that are still perpendicular to the canes at this point. Here's another picture. And this is, a few weeks later as you're getting into kind of pea-sized berries. What you're seeing here is probably when most people start using this tool for just regular leaf removal. So most people in Washington State are removing leaves on the morning sun side of the canopy for quality reasons, to degrade methoxypyrazines and to help with color development. And then you get the added benefit of increased spray penetration for your fungicide sprayers. And so after all these operations I've described, this is basically what our vineyard would look like after these operations. And actually, coincidentally, this is basically what our vineyard looks like right now as we speak here in Washington State. The clusters are starting to size up, and we'll probably be at bunch closure here within the next week. So this slide and the next slide are just showing you kind of final canopy for different tonnage goals we're going for. So this is about 12.5 tons per hectare, or as we described it as about 5.5 tons an acre. So this is our pretty typical, this is our higher yield Cabernet. And this would be our lower yield Cabernet. This is about 6.75 tons per hectare. The fun part about this project, as we've ramped it up, is it's, when I first started this from a business standpoint, it needed to scale. And a large part of our production is made for reserve quality wines. And so it needed to work in all of our highest quality vineyards as well. And it's worked quite well there. We've been able to be quite aggressive with these tools and really get the yield down and have the quality there where our customers want it. This is also Cabernet Sauvignon. So now that we've accomplished all these cultural operations, I wanted to talk a little bit about how to separate quality via map prior to harvesting. So this is a non-differential vegetative index map. We can use these to assess high vigor and low vigor sites. So the blue on this map would indicate high vigor, and the red and yellow would indicate low vigor.
Richard, can you close the screen that you are looking at so we can see all the details?
Oh, sorry, I didn't realize that was open for you guys. Is that better?
Yeah, thanks.
So again, the blue is high vigor and the yellow and red is low vigor. And we can use that to create, subjectively create zones for when we harvest. So this is an image I borrowed from a customer of ours. They use this technology as well. So you can see here they've drawn some red polygons to separate higher vigor areas from lower vigor areas. And what they would then do is you would load this map into a GPS unit on your mechanical harvester, and you would tie that into the equivalent of a traffic signal light. And so as the machine harvester, let me find my mouse, as the machine harvester is here traveling from south to north, the harvester would have a green light telling him to continue. And as soon as he exited this polygon, he would get a red light. And that would indicate to dump the grapes into one gondola versus the other. And so in this way, you're basically separating your grapes as you harvest them into two different gondolas, into two different harvest trailers, so they can then arrive at the winery and give the winemaker the control to keep these separate. The high vigor isn't always necessarily associated with poor quality. However, usually the low vigor is better quality for most of our customers. But in some cases, especially for white varieties like Sauvignon Blanc and other varieties like that, the higher vigor can actually be better for quality. But in any case, it really just allows the winemaker to have these grapes separated and allow him to treat them correctly in the winery and put them into the correct programs they're looking to put these into. Here's another example of drawing a harvest zone on an NDVI map to harvest separately. So now I'd like to get into the technology we're using to harvest. So this is you'll recall this is the same multi-use tractor that we were using for pruning earlier in the season, a Calanque tractor. And now we've taken off that pruning head, and you can see right here in the middle, in the over-the-road part of the tractor, they've installed the bow rods. So these green bow rods will basically ride along the trunk and the canopy. So basically right in the fruiting zone of the vines, and a little below and a little above it. And these will shake violently. They'll shake violently, and it will cause whole clusters, whole rachises, as well as individual berries to fall down here, and there's some catch plates here. And those catch plates are angled at a slight degree to allow the whole berries and the whole clusters to fall here to the conveyor belt. And this conveyor belt on both sides will bring the fruit up to the top here to the selected portion of the machine. So what I described so far is very typical for wine grape harvesters across a lot of years and decades, really. This is really the newer technology that we're finding to really help with quality. So this fruit comes up the conveyor belt to a different conveyor belt, and now we're in the selective portion of the Calanque harvest picking head. And so now you'll see there's another series of bow rods right here and here. And these small bow rods are shaking very violently, destemming these berries, these clusters. So the berries will fall off the rachises as these bow rods are shaking. The berries will fall, and they'll fall onto basically a sorting table with a series of rollers that sits on top of our collection bin. And then that'll allow the berries to fall through and the rachises to basically cascade off the side. And I'll show this in a little more detail here in a sec. So this is that sorting table I was talking about that the berries and the waste will fall onto. You can see that the rollers start with a very small window, and that window becomes larger and larger to ensure that your berries fall through before they fall off the edge. So here's a close-up from behind of that small bow rod I was telling you about that the berries get destemmed on. And I have a short video of that working right here. Show that again. Seems like the connection isn't providing very good quality. Were you guys able to see those videos okay?
That's fine. Yeah, more or less okay.
This is a video online from the Pellanc website that can show some of what I've talked about a little more clearly as well. So here, the clusters have already run through that descending portion, are now falling onto the sorting table. That sorting table is on top of a 1.5 US ton collection bin. And so you can see the waste on the top of the screen is cascading off the side of that sorting table, and the berries are running along until they find a hole large enough to fall through. And you can see even the smaller portions of the rachis tend to fall off, cascade off the edge of that sorting table too, instead of falling into the collection bin. And then I'll fast forward here to an area to show you like the quality of the pick. So a lot of people are worried about juicing the berries ahead of time and not providing the winemaker control of the maceration process. But if you set this up correctly, you really end up with a lot of whole berries, really no waste, and not very much juice. It's mostly whole intact berries, as you can see as they dump right here. There's not really much juice at all in that bin. So this has really been a game changer for us to really control quality in the vineyard as we're picking our fruit. We do have to keep in mind with that the tonnage decreases depending on the variety and depending on the year based on fruit set. So I've had our crews weigh the waste that comes off the side of that sorting table, and in Syrah it's been as bad as 9 or 10% one year that we were losing in yield, and on the low side of things you'll lose about 3% of your yield. So we're actually adjusting our bud numbers and cluster numbers up slightly to account for that loss to make sure we're still getting our yield goals, since we do get paid on tonnage for a lot of our acres. I'll skip this video here. This was just a video I put in just in case the internet wasn't working for that video. This final slide here shows basically where we're at currently in our vineyards. We have about kind of like peak-sized berries right now in our Cabernet, and we're in the middle of just finishing up our deleafing pass with our mechanical deleafers. And with that, yeah, thanks for your time, and yeah, I'd be happy to field any questions or comments anybody has. And then here's my email for any follow-up questions as well.
Hello?
Yes.
This was a very interesting presentation. I want to ask you if you do any soil mapping for fertilizer application. And the second question is about pest and disease management. So do you have any prognosis systems for when to apply and how to apply pesticides?
Yes, sure. So with reference to the soil mapping, we do our own vineyard development. We plant almost every year. We're still in kind of a growth phase, and we typically we have something called a Varus cart. I'm not sure if you've heard of that before, but it looks at soil depth and soil electrical conductivity, and basically allows you to subjectively define as many zones as you want based on the differences it's finding. And we'll use that to then basically tell us how to ground truth our soils. So we'll create a map with maybe anywhere from 2 to 4 zones, depending on how much variability we think we find. And then we'll go out there and we'll take soil pores by hand and have them tested. And then we will variably apply chicken manure and micronutrients based on what we find in those samples. Rarely do we have to adjust pH we typically, most of the soils in my area are fairly close to neutral on the alkaline side, maybe about 7.5. But sometimes we might find some very alkaline soil, and we will try to reduce our pH a little bit. And then as far as pest control, so we do a lot of scouting in the vineyard. So our main pest in central Washington, eastern Washington, our winters are cold enough where we don't have a lot of insect pressure. Our main pest would be spider mites because we get so hot and dry. And we monitor those visually with technicians in the field. We do have leafhoppers as well, but we mainly monitor those visually as well. The only thing we're really doing on the technology side is Oregon State University, I forget the gentleman's name, but he came up with a spore catcher for powdery mildew that helps you decide when you should start spraying. In Washington, even as hot and dry as we are, powdery mildew is still our biggest chemical expense just because we spray preventatively because of the economic issue it could cause if we have it. So people probably spray, on the low side, if you're really brave, maybe 3 times, but probably on the high side, maybe 6 times. Some people are starting to use that technology. I was working with the university on that last year. It's very interesting for when to start. It doesn't tell you much for subsequent primary infection events we have in the year if we might get a rain event of like 1/10 of an inch with 50-degree weather, because there's really no threshold for how many spores is meaningful. So it tells us when we find them early in the spring, it's like, okay, great, we know there's inoculum out there that could be causing an infection event, let's start. But after that, it kind of becomes kind of a useless tool for now until there's more data.
Okay, perfect. And is it the Pacific mite you have up there?
We have a few mites, and what's interesting is the Washington State University has been conducting some surveys, and they're finding new mites that we didn't realize we had. And actually, my viticulturist is an entomologist by training, and she's been finding new mites. So we do have the Pacific mite, the Willamette white as well. People always thought we had a lot of 2-spot spider mites, but we actually don't. So.
Okay, great. Thank you very much.
Sure. Okay, well, yeah, thanks very much.
Well, thank you very much for joining us today, and thanks for sharing all the information. I'd like to wish you a great day. You're still early in the morning there, right?
Yep, it's about 10 after 8 in the morning, yeah. Well, cool. Well, thank you. Thanks again. And yeah, I hope you guys have a great rest of your day too.
Thanks very much. See you.
See you.
Our final speaker for the day, Mr. Menelaos Stavrinides from the Cyprus University of Technology. He will talk about Mediterranean viticulture and the climate change, adaptation and mitigation for innovation.
Esta cuestión de ser necesitan bibliotecarios του UC Davis, κάποιοι συνοπία. Φυσικά είναι λίγο πιο αναλύω τους είναι τα κυρία πραγματικά. Φοβάμαι καλά έχουν Telepresence χωρίς πρεσβείες με έξι δηλαδή εγώ είπα πήρα κανείς στον Telepresence για πρεσβειοποιητικά και κανείς τρέψεις. Αυτό ήταν 4-5 speakers που εκδήλωσαν το κριτήριο του Cascade. Το γάσο ανάγκη να λίγο άρα για να μπορεί. Ανταλλάξτε στοιχεία, γιατί μπορεί θέλει να συνεχίσει να... Άρα απολέψεις. Ναι, κάνεις μου. Δεν υπάρχει και εγώ του 3 ώρες ήταν να μην έχω πέσει. Αλλά διαβάζεις να έχεις να το σκάζω. Και να πω μόνο είναι ζούσα να πεγάω πράγματα. Θέλω να κάνεις και πράγματα. Правильно всегда нужно боль. Εγώ λέω ότι τούτοι που θέλουν την εξαρτησία για εθνικιστές δεν είναι στα χωρικά. Μια ισπανικά που θέλουν να στabiliσουν
Πώς παρουσιάζεις?
So I think I will begin until my windows load. So the idea today was to give you an overview of the research we're carrying out at the Department of Agricultural Sciences. And unfortunately, we weren't aware of this event, so we haven't had a chance to have a longer time slot, but I would like to thank the organizers for giving us this opportunity to present today the research we're carrying out here in Cyprus. I think I can send my flash drive. Okay, so this is about the research from my group, the Sustainable Agriculture Group, and we work mainly on first developing sustainable viticulture practices tailored to the realities of Cyprus, because what Richard was showing was really impressive, but as most of you know, the situation in Cyprus is very different from that. And maybe in the not so near future we'll be able to apply some of those technologies. Some of the things he showed, I think, can find application in Cyprus, but the scale of viticulture is very different. It's much smaller, and so we'll need to start from the ground level to reach the top. And I think we are at a good point because we have several wineries that are interested in innovating, and that's there's a critical mass, but we're still far behind what we're seeing in other countries, which is not a big problem in my mind, because I think we can take advantage of the small scale of viticulture in Cyprus and the more traditional practices we're still applying in our vineyards. And so we have just concluded a 3-year project funded by the last instrument of the European Union. And the idea here was to identify sustainable practices with 2 aims. One was to minimize the pests that we apply in vineyards against one insect pest, the grapeberry moth, Lobelia botrana. And the other main aim of the project was to conserve biodiversity in vineyards. And we work in the Kumandaria region, here on the foothills of the Troodos Mountains in Limassol. And we were after a lot of work, because it's not easy to work with small-scale growers. It's much easier to work with a weiner. But most of our vineyard growers are part-time farmers. And so in their mind, they need to get things the way they are used to doing them, and it's not easy to convince them to change their practices. But we're able at least to show some of the practices, things we knew in advance, like these stone walls are very important for biodiversity purposes, and that you can keep the margins in your vineyards, because they are also very important for insects, birds, reptiles. And some of those measures were included in the funding by the Cyprus Agriculture Payments Organization. There are measures for high nature value farmland, as they are called. We're also, so this work is very, very basic compared to what George showed you before, because what our farmers are doing is they are holding that pesticide sprayer boom that George was showing in the greenhouse, but they spray their vineyards with that. So we have a lot of the solution going everywhere else, but not on the vines. So we're working with a PhD student, Kostas Michalis, who works for the Department of Agriculture, and he's trying to showcase and develop, using these new technologies, modern equipment, to lower the amounts of pesticides we're spraying in vineyards. Another avenue of research has been to identify which practices contribute to the high carbon footprint, specifically for vineyards in Cyprus. And what we found was that Cypriot varieties like Sinisteri have a much lower carbon footprint than these introduced Cabernet Sauvignon. This is per kilogram of grapes, the footprint, the kilograms of CO2 produced per kilogram of grapes. And then this Thompson seedless was much, much higher. This is used for table grapes, and as you must know, table grapes are much more intensive than wine grapes. And here we are seeing the hot spots for emissions for different varieties. And as you can see, fertilizer application is a huge contributing factor. And here in the table grapes, Thompson seedless, pesticides, the field energy use is also very important, because the growers have to do a lot of applications of pesticides and visit their fields much more often than the other two wine varieties. And I'm going to conclude with this slide where we're showing our future research. We have succeeded in receiving funding from the Cyprus Research Promotion Foundation. On this, well, there are two options. We certainly have received funding for a project under the Excellence Scheme, and that's in collaboration with one small winery, the Michalis winery. And then the idea is to develop the product environmental footprint for wine in Cyprus. This is a new concept in the European Union. Even for the EU, it has not been developed fully yet, because we're lacking the biodiversity aspect. There are 4 parameters that need to be taken into account: the carbon footprint, water consumption, fertilizer use, basically overuse, how much of what you're applying ends up in the water, and the biodiversity impact. And this biodiversity impact is yet undefined, and we're going to work on that. We're trying to reduce waste from wine production by developing an organic soil amendment. And we're also working on developing a sustainable wine quality mark, with the idea being that wineries that apply these, I would say, simple, for the most part, practices that protect the environment and put a label on their wines and make them more appealing to consumers. And this is, of course, not an idea that we thought out of the blue. It's a well-tested idea that works in other countries, and I'm showing you here the one for New Zealand, the one for, I think this is for Italy, and then there are several in the States. This is for Lodi in California. And in addition to the research that happens in my group, we have people working on the adaptation to climate change, meaning they're working on varieties that are adapted to the hot and drier conditions we expect in Cyprus. And Sinister is a very promising variety. Sinister is a white variety, an indigenous white variety. We have other colleagues looking at quality of Mandaria, and this is George Manganaris. Dimitris Tsaltas is working on several aspects of winemaking. I think one of the last projects is about developing wines using yeasts naturally present in vineyards. And we have another colleague, Lucas Canedis, who is working on managing wood diseases of vines. And that's all. Thank you very much. And I'll be happy to answer any questions. Questions?
You said to us that you are examining the biodiversity. Which species are you examining?
Yeah, we're examining basically reptiles, birds, and insects. And we work with colleagues, so we do the insects, and we work with colleagues from the Open University of Cyprus, the Department of Environment, for experts on reptiles and birds. Yeah.
You also examine the microorganisms?
Plants as well. No, we don't. Maybe we should be doing this because so we submitted another project to the Cyprus Research Promotion Foundation. It's called an integrated project, and it's a two-stage. And on the second stage, the interview, I got the same exact question. So we don't, but if you're interested, we'd be very happy to collaborate. Thank you.
Thanks very much everybody for coming. Over here we have the center for everybody to use. So I should also work with Dimitris, if you're interested in here.